Yeah, this talk is not about KMP. I don't know, well, nothing about KMP besides what I've heard right now. But it is technically cross-platform because passkeys as a concept are currently present on all major platforms. You're going to hear about that soon. So yeah, hold on tight. To go over things, and this is not working. Oh, it is. All right. Cool. So to go over things quickly, we're just gonna have a quick introduction and a story about passkeys and what they actually are. We're trying to compare them to existing authentication methods, which are primarily passwords. And then, why I'm guessing you're all here, is to look at the Android implementation of passkeys and finally have a conclusion, then we can go home. Actually, not home, but to the fridge. All right. I'm gonna do this. Cool. So a quick story about passkeys and something called WebAuthn, because without WebAuthn we can't talk about passkeys actually. So the textbook definition of WebAuthn mentions something called strong, attested, scoped, public keys, credentials, yada yada yada, but that really doesn't tell us a lot. So going step by step into it. WebAuthn is just an abbreviation for Web Authentication API. It has been built by W3C and the FIDO Alliance, plus a bunch of different people from a bunch of different companies like Google, Mozilla. There's YubiKey guys, Yubico who made YubiKey. There are guys from 1Password, a bunch of different companies. And this is important because this really shows you how wide the net is cast on defining this API and the standard, and then it's going to be important for passkeys as well. Next up, it's a public key cryptography based standard. So you all know what public key cryptography is. It's nothing more complex than that. And the fact is that with it being so safe and so used and so standardized, it's something that can easily be then used within the standard. In addition to that, there is a need for a strong, necessarily device-based authenticator. Something like the Android biometrics system, the Apple Touch ID or Face ID, Windows Hello. You can also use physical security keys or something else entirely, but it needs to be a physical device-based authenticator. And all of that is then a standard on which the passkeys are based on. So now that we know that, let's go see what passkeys are conceptually. So the coloring book for passkeys. You're gonna have a private and public key pair. With that, you're gonna have to have that authenticator device. So the private key of the pair is gonna live on that authenticator device and will never leave that device, which is a very important fact. And of course, you're gonna have your server, the same one that you're gonna have if you're using passwords, like you need to send that data somewhere so that the server can say, okay, you are that user who you say you are, voila, there, you can log in. And of course, these two communicate, but necessarily via HTTPS, because if they don't have the secure part of HTTP, well, everything just falls down and you have no point in cryptography or security or anything else. All right, now let's try and compare passkeys to passwords. The first question that we have is like, why do we need passkeys? We have passwords. Aren't they good? Well, not really. By Verizon, they have their yearly data breach investigation report. This year, they found out that about 68% of breaches include some kind of a human factor to it. So this can be anything from social engineering to phishing to just getting your password in some way or another, or using a person to then access some other authentication mechanism. And in addition to that, 80% of breaches are somehow linked to passwords and, well, them being just low quality. So, going step by step on why passwords are essentially bad. First and foremost, we as people are not good at remembering random strings, because a good password needs to have uppercase, lowercase letters, you need to have numbers, special characters, and it needs to be probably this big. So we all are not keen on remembering that stuff. So what do? We use something that's rememberable. We use 1, 2, 3, 4, 5, 6, which isn't good, because these simple passwords then can be very easily manipulated and accessed via social engineering, which mainly presents as phishing. So the idea is that you have to have a complex password, but then you don't remember it. So you use a simple password, and then someone, well, easily gets that password from you. And by statistics, there's like 85% of users or something like that that use very simple, easy to remember passwords that then get leaked or stolen or something like that. In addition to that, there are mechanisms if you have a, let's call it a simple password, to protect yourself additionally by having multiple factor authentication systems applied, or using password managers for building complex passwords that you don't have to remember, but then use password managers. But the thing is that an average user does not use those and probably don't even know them. All of these are opt-in mechanisms and not opt-out mechanisms, so we don't have a large user base using those. In addition to that, if you have a good password, if you have a lot of things set up, there are still chances that your password is stored somewhere on a Chinese server in someone's basement and it's going to leak, and then you're out of luck, especially if you do what most users do and use one password for everything that you have, from Gmail to Facebook to your Tinder account to whatever else. And finally, us developers have headaches with storing this data securely so that it doesn't end up leaking somewhere else. These all are just some of the points why passwords are bad. And for some time now, there has been an idea of trying to replace passwords with something, but like 10 years ago or something like that, the guys from W3C and FIDO actually came down and said, okay, let's think of something, a mechanism that can improve all of these points. And so, the benefits of passkeys. First and foremost, a passkey has actually 3 points of contact, let's call it like that. The first one is that you have that private-public key pair. The second is that you need to have that physical device, so the authenticator. And the third one is that you need to have that device locked somehow. So if you're using your phone, you have to have some kind of a lock screen. Is it a PIN, a pattern? Is it something probably more secure like biometrics? But these 3 things make a passkey much, much more secure of a combination than just having a password. And having a password with something like 2FA. Secondly, it's resistant to phishing. Why? Because if you remember the initial kind of coloring book, you have the public and the private key. The only thing that is, let's say, available to the public is that public key. And that's being stored on a server for your Facebook account or something like that. The private key never leaves the device that it has been registered at. So even if someone says, okay, let's fake a Facebook page and have you log in to there, that's not going to work, because the actual concept of that public-private key does work only for a single domain that's registered, that's confirmed. You're going to see in the implementation what actually needs to go down for the passkey to work. Then it's unique for every service. So the thing is that each time you create an account for something, a new passkey is being automatically generated. There is no chance in hell that you're going to have an old passkey that you use for Facebook that gets reused for Instagram, or if, okay, maybe not Instagram because it's the same company, but conceptually, yes. Each and every service that you register to has a separate passkey. So you don't have that, you automatically have that benefit of preventing users from using one password for everything that they have. Then it requires 0 bytes of human memory because there's nothing to remember actually. You never see any code or characters or anything that's being actually cryptographically protected, because the only thing you're going to be seeing is some kind of a native platform mechanism of choosing which account you want and then giving your biometrics or screen lock or something like that. All right, and finally, it's smoother. The thing is, you're going to see how it looks like. You don't have to input anything. You don't have to input your username and then your password, and then you probably mistyped it or something like that, or you have to use password managers. This simply works, and actually by statistics, TikTok and Kayak and Amazon all reported on Google I/O this year that they had an almost 10-fold increase in the speed of their users logging in by simply using passkeys instead of reverting to passwords. The thing is, there are downsides. It's not an ideal world out there. So point number one is passkeys themselves are still not as secure as physical security keys from like a YubiKey or specific platform authenticators. Because if you're using Android or iOS as your primary authenticator device, they do offer, and this is a good thing for most users, they do offer syncing passkeys to iCloud or to Google Password Manager. I'll mention why that's good, but conceptually this is a security issue because you have those passkeys present outside of the device that you created them on. Secondly, what the hell happens if I lose my phone? And we said that our keys are stored on our phone, and then our phone goes out the window and now you're locked out of everything that you have. Well, going back to point one, we have mechanisms of syncing these passkeys securely, of course, as far as iCloud and Google Password Manager are secure. We have mechanisms of syncing those between different accounts. And also, in addition to that, you can, most services offer that, I don't see why they wouldn't, you can create multiple passkeys for like multiple devices for a single account. So if I have my Infinum account and Infinum starts supporting passkeys for my login, I can create one passkey from my phone, second one from my laptop, and third one from my private laptop or something like that. And all of them link to the same account, but if I lose my phone, I still can use my laptop to gain access to my account and then delete the passkey or something like that. Okay, then we have an issue of error handling across platforms, which is still in process, so it's not ideal. Sometimes it's complicated. You'll see all of the different error mechanisms that can pop up in the Android SDK. Another point is, well, going back to our users, passwords are just something that they know. They understand that, they know how to use them. They have been struggling for the past like 40 years with them and trying to figure out how to use passwords without their photos leaking out on various different media. And they kind of finally understand that. And if you try and jump them over to something that they literally do not understand how it works, you're gonna have trouble. And that's probably the main issue of any new technology, especially something like this. And currently, again, from the user standpoint, there's only a handful of services, like most popular services, that currently offer support for passkeys. So there's Facebook, Amazon, Google, stuff like that, but your local bank probably will never have passkeys or something like that. And it's the problem of just having adoption to support passkeys within your app, yada yada yada. And sometimes, as everything, it just doesn't work and it dies upon you. I had trouble registering my Google account with passkeys, failed miserably, and that's why I had to run to get my phone and use 2FA. All right, so if you go to passkeys.dev, you have a very up-to-date spreadsheet of the current support of passkeys through various different platforms. If you're going to be looking at Android, it has most of the things supported, iOS as well, even more than Android, and macOS, Windows, Ubuntu, well, most of the most important things. There's one thing that I would like to go over specifically, and this is cross-device authentication, because if you look at Android, the cross-device authentication allows Android to be the authenticator. So it allows you to use your Android phone to log in to Facebook on your MacBook or something like that, but what it doesn't allow is the client option. So you can't use your MacBook to sign in to an account that's on your device, to an app that's on your device. That's still not supported, but it's somehow planned. We don't know when. All right, now going through the code. Some prerequisites. First and foremost, it doesn't work below Android 9. Below Android 9, you're going to be stuck with passwords, sign in with Google, or whatever else you already had before. Secondly, you're going to have digital asset links association with the website, so with the server, technically, that you're trying to authenticate with. And thirdly, the simplest and the best way to actually implement it is to use the credential manager from Android X. The credential manager offers, well, technically everything you need. It has a mechanism for creating passkeys, for using passkeys. So, plus it also has mechanisms for storing passwords, and it allows you to implement sign-in with Google. So most of the kind of common ways of authenticating users can be done through just a single API. Not that that's good, knowing Google's history of killing things, but yeah. Secondly, it offers a system bottom sheet UI that pops up, and then you get to pick your account, give your credentials, and simply log in. Thirdly, since like last year, it supports third-party password managers. So technically, you can use 1Password, LastPass, a bunch of different other password managers to store pass keys, not just passwords, so that you can then also have another platform if you don't trust Google or Apple, which makes sense. Then you can use something like 1Password to store those passkeys and share them between multiple devices, and Credential Manager now supports that as well. The only thing you have to watch out is which one you import, because there's the Credential Manager from the regular Android SDK and one from Android X. Use one from Android X because, well, you're just not going to be able to find these new methods for passkeys. All right. Let's go into two different flows. First one, we're going to be going through a flow of registering a new account with a passkey. And secondly, then we're going to be looking at the way to use that account to log in with a passkey. Just so that you have a rough idea of how it looks, I tried to register a passkey for Amazon with my personal account. And then a pop-up jumps out, says, okay, you want to create a passkey for this service. There's an account that's going to be used. You can choose another account if you want to. You press continue, and the only thing is that I couldn't screenshot that because of Android privacy reasons. A system bottom sheet for giving biometrics pops out. You press your fingerprint or give your Face ID or something like that, and it automatically does everything for you. You now have a passkey, and you're being led to the success screen. So that's the registration process, and that's it. And that's why it's usually simple for users when it works. How does the flow itself work? Well, now we have three different components. We have the authenticator, we have the client, and we have the server. If we're working from the mobile perspective, so we have an iOS or an Android app, the authenticator and the client are usually one and the same. It's just the authenticator can be presented as the credential manager, and the client is, well, your app. All right, so first and foremost, the user requests a registration process that's being sent to the server, and the server creates some kind of a very weird JSON response that you're going to be seeing very soon for a configuration of that new registration process. After we have that, we pass that configuration to the authenticator, so to our credential manager. It takes that JSON, a very specific JSON that's being defined by the standard, and it returns some kind of a prompt to the user for verification. So that's the bottom sheet pop-up that you witnessed. After that, we successfully complete our verification process, and that's being sent over to the authenticator. Okay, success, yay. The authenticator then, since this is the registration process, it creates that new public-private key pair. It uses the public key and sends it over to our server, and the private key then stays secure on the device itself. On Android, it's being stored within the Android key store system, and on iOS, it's being secured in the Secure Enclave. And finally, our client, our app, gets some kind of a configuration of a public key, sends that to the server, and we're done. That's it. How does that look within the code? All right, so step number one, we call the server, we get the configuration. That configuration is that request JSON parameter that we send into the method called create public key credential request. That method is within the credential manager, and it simply creates a verification request that we're going to be then verifying by giving our biometrics. All right. So how does this configuration response from the server, the initial one, look like? It looks like this. It has a couple of key points to it. The first one is something called the challenge. It's randomly generated, and it's basically an ID of your registration request. Secondly, you have the pub key cred parameters that are the supported cryptography algorithms, which -7 and -257 are something very generic and common. One is RSA with SAJ256, and the other is something. But the thing is that your server, if you're building a complete solution yourself, your server can then define which algorithms it considers safe and which it doesn't consider safe. So if you have an authenticator that doesn't support any of the algorithms that are listed here, you're going to be failing your registration process. Thirdly, we have the user ID, again, randomly generated, and of course we have some kind of a name and display name. In my case, that was my name and the account that's being shown on the bottom sheet. By specification, these last ones are not necessary, but just because of a better user experience, these are the ones that are going to be showing when you open the bottom sheet. So yeah, it makes sense to fill them out. Okay, now we have this try and catch mechanism, which calls the credential manager, and it uses that request that's being created to simply create credentials. The entire call is it. So this process, when you call create credentials, it takes in the configuration from the server, it wraps that up in something very nice, it provides that to the credential manager, it shows up the bottom sheet, you pick the account which you want to use to create your passkey, it automatically requests some kind of a verification process from the user, and it gives you out a result. This result is then handled. You check it for all the parameters that you need, or option B, you get the create credential exception. And now, when you have that create credential exception, you have a couple of different options to choose from. And some of them are very clear. You're either missing a dependency, or you're gonna have to use your third-party SDK documentation to see whether you're actually getting from them. The user has canceled something, but there's always the unknown exception where that's literally everything that you get, no other explanations. So yeah, there are a bunch of different ones, especially the first one, where you get DOM errors that are only strictly covered and defined by the WebAuthn specification, so you have to go through their documentation and then dig through things. And then the option B was success. You get some kind of a create credential response from the manager. You check if your credential is the type that you wanted, because the manager can return various different types under the same class. So you just have to check that. You get some kind of a payload. So it's pre-made, it's by standard. You just take that payload, send it over to your server, and you're done. All right, logging in should be a bit simpler. The login process then looks like you get to a login page, or you're within your app, and you have an option to use a saved passkey to log in. You're welcomed by a prompt from the credential manager who says, okay, you have a saved passkey with this and that account. Choose that one, use your screen lock or whatever else you have for gaining entry, and that's going to be it. The flow itself, again, it's similar. So the user, of course, has to initiate the request to log in, and then a server creates some kind of a challenge, which is then returned and passed through to the authenticator. So the process is very similar. The server creates something that's being sent over to the authenticator. The authenticator then uses that information and requests a verification from the user. Once that's complete and the verification is successful, the authenticator uses the private key to sign the challenge and sends that signed response to the client. The client then takes that, of course, takes the public key, confirms that everything is well and right, and returns a response to the client, to our app, saying, okay, this is good, this is a correct pair of cryptography keys, or it's not, and then you have a failure case. And that's it. How does it look like within the code? So again, you have some kind of a passkey, login, config, response, whatever else that you're going to be getting from the server initially. That's the challenge that you're going to be feeding into the credential manager. This challenge is relatively simple. So yeah, I did this presentation for DroidCon, so that's why it's left here. The thing is that it has to have a process ID or some kind of a relaying party ID of that web service or that server that you have been registered to. Now, when you get that challenge, you use it to wrap up a get credential request, feed that to the credential manager, and considering it doesn't have any special methods, so get passkey credential or get password credential or get sign in with Google credential or whatever else, it only has one method. It can take in a list of different requests, and that's why you have to check every time when you get a result if your request matches the result by type. So if you used a passkey to log in and it returned a credential that's a passkey type, and that's the only kind of limitation of the current API. You get that credential. If you get an exception, well, yeah, you're out of luck. But if you succeed, then you check the result. If it's a public key credential, that's what within the API they call a passkey. You can take that, wrap around the assertion, so the now encrypted challenge with the private key. Take that, send it over to the server, and then have the server do their thing, and that's going to be it. All right. There is an app demo of this. All right, where we are. Cool. So yeah, I made just a quick demo with a login example. Why are you not scrolling? All right. Cool. So here, when the user clicks login, we have a method get public key credential option. This is within the credential manager, and we give it some kind of a JSON that's specified with the standard. So that's, come on. All right, this is just a mock, so that I don't have to have an API. So this is a JSON that matches the standard. We use that, and this generates some kind of a passkey request. All of the credential manager latest methods are coroutine methods, and they're also spend functions. So you have to have some kind of a coroutine scope to call all of them. We have that request with our JSON response, which contains the challenge key. We call the get credential, we take the result and process that, and then we can call it a day. That's the login, and the registration looks fairly similar. All right, so we have a mechanism of just confirming that we have some kind of a username, an email, we create a new passkey. All right, so the mechanism is the same as demonstrated before. So we have this create public key credential request, which is again a method from the credential manager. This is just a mock of the response for registration. It has a bunch of different points that we already demonstrated through the presentation. And cool. This returns us a request for creating a passkey. We use that to call create credential. It returns a result. We handle that result, or option B, we handle any of these errors that might pop up. And that's it for the implementation. Finally, the conclusion. So first and foremost, passkeys are simpler and proven already to be faster for end users. Secondly, they are more secure and they are cross-platform capable, unlike passwords. Thirdly, it's important to note that they are only compatible with Android 9 and above, but if you're using Credential Manager, because, well, you should, the Credential Manager automatically allows you to use passwords or sign in with Google for any version of Android that's below 9. And finally, whatever we may tell to ourselves, the death of the password is going to be a very slow one, not because of the technology or us as developers, but just because of the users that are gonna be struggling with, changing their IT lifestyle. And yeah, that's it actually. Any questions? Yeah.
What happens if you
No, go ahead.
What happens if you lose your only device, like you store the passkey? Like, let's say I lose my phone, but I don't have any other device that stores like another passkey to log into my account. It is then to the platform to decide what recovery method I will use, or is there like something different here?
Yeah, that's a good question, and the answer is that you're depending on which platform are you using, you're either out of luck or you need to have an Android 15 or above. In Android 15, presented just on Google I/O this year, the new version of the Credential Manager API is going to allow automatically if you allow backups for your apps. It will allow for a copy of the passkey to be stored securely. And in case you want to back up your phone, so you lose a phone, and that's the only way you've created a passkey for a service, you buy a new phone. You use your Google account to recreate every app that has been installed on your old phone. If you have an Android 15 Plus and that app was installed there, use the passkey and you backed it up, it's gonna be reinstantiated on your new phone with that passkey. Otherwise, you're shit out of luck.
Yeah, but isn't that like a security concern? Like Google stores my passkeys then?
Absolutely, absolutely, and that's then the question of how comfortable are you with Google knowing your passkeys and also passwords, using sign-on with Google, a lot of different things. So yeah, you can only bet that Google cares enough about lawsuits to have their security game on point.
What happens if you don't have any, lock screen on the phone?
As far as I know, most systems will just prevent you from creating a passkey on that device. So you have to have at least something. You can't have just a swipe to open. You have to have a PIN, a pattern, something. You don't have to have a biometric system. It's definitely a better option, but you don't have to have it. You just have to have something. Željko. Oh, sorry.
But you can have passkey, let's say, for your Facebook account and also a password for your Facebook account.
Yes. That's up to the system to support, but like 100% of systems currently support passwords, and that's not going to change. So they're still going to have passwords with passkeys. You can, as a user, decide that once you create a passkey for a service, for a Facebook account, that you're going to remove your password. Delete that authentication mechanism, but that's your own free will. And in case you do have a password as a backup, if you lose a device and you don't have other options, yes, you can use a password to log in again.
But how does it look then? If you remove your password, how can you log in without the device?
Okay, so yeah, actually that's something that I haven't really mentioned, but let me quickly find it. That spreadsheet thingy. Where are you at? All right, cool. This cross-device authentication mechanism, that actually offers you to use your phone to log in via passkey that's stored on your phone to a website on your Mac. And it works, so it works from Android to, well, mostly everything, and from iOS to mostly everything, but no other devices for now can be authenticators. So they cannot store passkeys on their own. They can only be the clients in this conversation. Basically how it works is via Bluetooth. Your laptop, so be it a Windows, a Mac, or Linux, or something like that, creates a secure connection via Bluetooth with your phone, and it shares this data about a passkey. The mechanism is mostly the same. Google Chrome has that implemented very neatly. It just shows you a pop-up, hey, use a passkey. We see your phone. Do you want to use that one? Yeah, cool, use your phone. It connects automatically, it disconnects, and that's it. Željko.
Yeah, so you pretty much said that we need to trust Google, that they're going to do everything that they can in order to securely store the passwords and everything else. But actually, we can say this is a hypothetical situation of what happens if Google loses those keys. But on the other hand, the geniuses from LastPass actually lost their master key and leaked it online, which means the whole platform is now compromised.
Yep.
So for instance, let's say in hypothetical situation, one password, Google Drive, or Apple iCloud, it doesn't matter. They leak all of your private keys somewhere. What happens then? who needs to revoke the passkeys? Like, does this happen on server? What does happen on mobile? So, what are the necessary steps that someone would have to do in order to mitigate that kind of hypothetical situation?
Mitigate it as a user or as a service provider?
Let's just focus from the developer perspective.
Mhm.
So, for instance, let's say the application that you have now developed.
Mhm.
Let's say that the user is backing the user is backing up the keys on Google Cloud, and Google Cloud gets compromised. What happens?
So as soon as Google Cloud, in this case, reveals an update that they have been compromised, and they urge everyone to take necessary precautions, the only thing that you can do as a service provider is cancel and revoke all of those public keys. That's the only thing you can do. The thing is that you do not know from which platform your key came. Maybe you do, maybe there's some kind of a specifier if it's from a Google device or an iOS device or something like that. But you definitely do not know if that passkey has been stored somewhere else. You just have to, wipe everything. That's the only thing you can do.
And how, like, in case of LastPass, they needed, I don't know, 4 months, 6 months, 8 months, something like that, to publicly confirm that they fucked up, pretty much. Like, do you really think that Google and I1Pass and everybody else will be completely transparent with what's happening with the platform or not?
Probably not. Probably not. At one point in time, yeah. But as you said, it can take 6 months, a year, 2, 5, I don't know. That depends on how tight a ship they can run before something leaks from somewhere. But that can happen regardless. If you use passkeys or passwords or any other authentication mechanism, maybe apart from a physical security key. But yeah, the mechanism is the same.
Is there an option in Credential Manager that you disable the passkey backup?
Yes, you do not have to allow syncs of your passkeys. So you can choose that your passkeys just live on the device that you have, and for Google or Apple or whoever else not to sync it. And then it's your sole responsibility. And the private key lives within the key store, the security enclave, and that's it. It doesn't move.
Because I see a lot of problems with potential clients, just trying to upload this thing.
Yeah, of course. The only limitation is that you as a developer, as far as I know, can't restrict users from syncing their passkeys. They have to do it manually, and that has to be their decision.
You can disable syncing the passkeys.
So yeah, if you create a passkey for, let's say, a banking app, and you create a passkey as a user, and you as the developer allow the user to use a passkey, the only thing that you cannot do is prevent the user from deciding if they're going to be syncing that passkey to Google or Apple or whoever else, or they won't.
Which means that the safest option is to disable the passkey generation for the user for that app.
Conceptually.
Okay, thanks.
Is there a way to just export it into something that you can just offer the user to here's your passkey? This is how it looks like.
No. You as an end user, or even you as a developer, I don't think you're ever going to see the raw data that's behind the private and public key.
Because you could log it somewhere to the server.
Absolutely. And then you're a security exception by yourself. Cool. Any other questions?
Regarding that question, can you force that to create a passkey must be hardware-backed device, like YubiKey or what the Google's key code? Like for biometrics, you can require that it's more secure hardware protected, something like that. Is also here an option?
Yeah, I understand your question. It's a good question because I don't know the answer, but I can only guess that you could do something like that based on the defined security algorithms. So that's one way of doing it, and maybe if there's something else within the JSON. Come on, move. All right, cool. Yeah, that's mostly it. Maybe there's something within this authenticator attachment. Maybe there's a way to define that it has to be a physical key and not just a mobile device.
Yeah.
But then you're maybe just better off using a physical key and not trying to mix a physical key with passkeys and stuff like that. But as I said, I'm not 100% positive on all of this. Cool.
Is that it? Yeah.
All right. Thank you.
One question.
Oh, sure.
So if user must enable, I don't know, some biometrics, something like that, And what if users then disable this? You can always turn off biometrics, What then happens with the passkey?
The passkey isn't connected to a specific mechanism of opening the phone. It's just connected to a mechanism of opening the phone. So if something like this happens.
You have passkey?
Yeah.
And then you get this prompt, but you disable biometrics. So
Yeah, but you still.
you just fail or something.
No. You're still gonna get a bottom sheet, but instead of asking for a fingerprint, it's gonna ask for a pattern or a pin or whatever else you have. Then it's gonna fail. Then it's gonna fail, yeah. Because the way that the key pair is being created, it's using a some kind of a I'm missing the word. A certificate, yes. Some kind of a certificate that's baked within the device. And that's being basically saved within the device. And that certificate can be accessed from anywhere but the credential manager. And it can only be used if you have some kind of a mechanism to unlock your phone. And without that mechanism, you can't access that certificate. You can't create passkeys. You cannot then use passkeys. So yeah, that's it. All right. Anything else? I'll be here for a while. So if you have any other questions, you can just come up. All right. Thank you.